Today we're going to be looking at the question number 4 from the 2002 AB exam. I've classified this as a type 3 interpreting graphs question. So let's get to it. Right away we have a integral defined function. The graph of the function is shown, so here's our integral defined function. I think that it's beneficial anytime you have a integral defined function to write directly next to it g prime of x is equal to the derivative of the right-hand side. And the fundamental theorem tells us the derivative of the integral is equal to the integrand when you're in the form constant going to x. Consequently, now that we have the relationship between g prime and f, we could write also g prime prime of x equals f prime of x. So those two pieces of information will help us connect ideas. In part A, they want us to evaluate g of -1, which is going to be the integral from 0 to -1 of the function. Let's be consistent with our notation, f of t dt. So when we look at the graph here, the area from 0 to -1 is the area of this triangle. We are working backwards and we are above the axis, so that is a negative accumulation. So the negative accumulation backwards and above of a triangle, that's 1/2 base times height, and that gives us an answer of -3/2. They also want us to find g prime of -1. Well, g prime of -1, given our relationship, is the same thing as f of -1, which we can look at the graph. F of -1 is 0. And then lastly, g prime prime of -1 is equal to f prime of -1, which is asking the question, what is the slope of the graph f at x equals -1? So we turn to the graph and we see that it is a straight line, so the slope's easy to calculate. We rise 6 for a run of 2. Rise 6 for a run of 2 gives us a slope of 3 units. This is worth 3 points. If you showed your work that led to these answers, each one of these is worth 1 point. Moving on to part B. For what x values in the open interval -2 to 2 is g increasing? So g is increasing when g prime of x, which is the same thing as f of x, is positive. A function is increasing when its derivative is positive. So f of x is positive on, this occurs on the interval -1 to 1. Pretty straightforward, easy 2 points. 1 point for the interval and 1 point for the justification.
Okay. Shake it!
All right, let's move on to part C. Part C says, for what values in the interval -2 to 2 is the graph of g concave down? So we're asking a concavity question. So g of x, or g, the graph of g, let's use precise math language. The graph of g is concave down when g prime prime of x, which is the same thing as f prime of x, is less than 0. Consequently, f prime of x is less than 0 when f of x is decreasing. So we're going to look for the interval for where f of x is decreasing. So we go up here to our graph, f of x, the graph of f is decreasing from 0 to 2. This occurs on 0 to 2. This is worth 2 points, 1 point for the interval and 1 point for the justification. So the justification being that the second derivative of g is less than 0. And they accepted either saying f prime is less than 0 or f is decreasing. Both of those work. Okay. Okay, part D. On the axis provided, sketch the graph of g. So g is expressed as the integral from 0 to x. So if we were to integrate from 0 to 0, we would get a total accumulation of 0 units, which means we know there's a point that exists at 0, 0. Furthermore, because of part A, we know that g of -1 is equal to -3/2. So it's down here. But going through and plotting points is not a very efficient way of sketching a graph. So let's look at this based on intervals of where things change. We'll start with 0. From 0 to 1, g of x will be increasing because the derivative is positive, and concave down because the derivative is decreasing. So from 0 to 1, we need to be increasing and concave down. From 1 to 2, the graph is going to be decreasing because the derivative is negative, and the graph will be concave down because the derivative is decreasing. So decreasing and concave down. Furthermore, we could say because of the area of this triangle and the area of this triangle being equivalent, we will return back to the same g value. In other words, g of 2 is equal to 0. So g of 2 is equal to 0. Working backwards, we can do the same thing. On the interval from -1 to 0, g will be increasing because the graph of g prime is positive, and g will be concave up because the graph of g prime is increasing. Increasing and concave up. And then in the last interval from -2 to -1, the graph will be decreasing because g prime is negative, and the graph will be concave up because the derivative is increasing. And just like previously, these two triangles' areas will cancel each other out, and we're able to deduce that g of -2 is also 0. So we get a curve that looks somewhat sinusoidal in nature. It is not a sinusoid, but it's kind of like a sinusoid. It's closer to like two parabolas tied next to one another. Okay, thanks for watching. The final 2 points comes from, do we have those 3 points at the correct location? And then, so that's 1 point for those intercepts, and then the other point comes for capturing the behavior of the intervals. So be sure to comment, like, and subscribe. Have a good day.